All right, now let's talk about the cases where you have constant acceleration. So you want to use this equation, V equals R omega, right? This is like you link them. L equals R theta. So how you link the linear with angular, right? So coming back to this equation, now when you say constant acceleration, okay, if it is not constant, say if alpha is zero, if alpha is zero, then we can use omega equals delta theta over delta t, right? If the question is asking for any value, we just need these two parameters, these three you can say, yeah? But what if alpha is not zero? So if alpha is not zero, then we use the four equation of motion here. See? Recall this. So first equation here for linear, this is V equals VI plus AT. So we use this equation when something is not given, right? So what is not given to us? You want to use this equation when distance is not given, right? Then x equals VIT plus half AT squared. So when do we use this? When V final is not given, right? How about next? This one. V squared equals VI squared plus half AX. So we use this when T is not given, right? So when we know that what's not given, we use that according to it. How about this one? This is V average, right? Equals V plus VI divided by 2. So when you want to find average velocity, you can use this equation. Now coming back to the angular side. So if you want to change this, we know that V is omega, A is alpha, T is remain as T, while X we say is theta. So let's just change this to omega there, right? So you change omega final, and this is initial velocity, you make it omega initial, and acceleration change to alpha. T remains the same, see, right? So here, even this X is converted to theta, VI is omega I, right? T remains the same. Half remains the same. Alpha is A, right? So T remains the same here. So you do the same thing even for this equation here and even for that equation. So you get the average angular velocity by doing omega I, omega final plus omega I or initial over 2, right? Okay, let's look at an example here. So you have a centrifuge rotor that accelerate from for 30 seconds, okay, from rest to 20,000 round per minute. The question is, what is the average angular acceleration? So they're asking for acceleration. What I'm going to do is I'm going to start by finding omega first. Omega equals 2 pi f. Remember that this is given to you as frequency. This is the frequency, but you have to convert it to per second because this is per minute. So how do I do that? Just divide this by 60, right? So 2 pi times f, and divided by 60. So this is my omega. Okay, from rest mean omega I is 0, and this is omega f, right? Final is 2 pi times f, which I just found out from here. What else do I know? I know the time t. What do I want? Alpha. Okay, so I'm just going to use the equation alpha equals omega f minus omega I over t. Because I know t, I know omega I know omega f. So plug them in because you were asked to find alpha. So alpha is here, this value, omega f minus omega I divided by t. So this is my answer, 70 radians per second squared. Okay, all right, next. Through how many revolution has the centrifuge rotor turned during its acceleration period? So I need to find theta now. Okay, so according to this, I'm going to use the equation here for theta, this one, right? I know omega I know t, I know alpha. I can now plug everything in. So t is 30 seconds, Omega I is 0. Alpha I just found out from here, 70. So plug all in this equation. So omega I is 0, right? Half alpha is 70, so you put 70 and t squared 30. So I got this as total number of radian it had spin. Okay, so what was the question asking? How many revolution? So I can divide this by 2 pi to get number of revolution because one revolution is 2 pi. So take this value divided by 2 pi. Okay, so you get 5 times 10 to power 3 revolution or 5,000 revolution within 30 seconds. Okay, all right. Now this is another example. This is new topic about rolling motion. Okay, so when an object rolls here, you can also say that you can find the linear velocity if you know omega and the radius. Okay, so let me just explain this one here. So this is a bicycle slows down uniformly from 8.4 meters per second to rest over a distance of 115 meters. So each wheel and tire had an overall diameter of 68 cm. So the question is, determine the angular velocity of the wheel at initial instant t equals to 0. Okay, that's easy. Omega equals v over r, right? Omega was supposed to be found, but v was given here, vi, and r is given to you. This is the diameter. So r is equals to 68, 0.68 divided by 2 because it's a diameter. So you get 3.4, 8.4 divided by 0.34. So you get 24.7 radians. Okay. All right. So next question is the total number of revolution, okay, it made before coming to rest. So I know that radius, this is the circle, right? And the distance here is 115 meters. So one revolution is 2 pi times r. Okay, and how many revolution is it? So I will just take 115 divided by the circumference that it is rolling. So I will get the total revolution. So this is what they did. Put the value of r in, you get 53.8 revolution. Okay, the rest just apply the equation of motion. All right, let's see concept of torque. What is torque? Torque is called the turning effect, okay, of force. Okay, you can also call this as moment, not momentum, yeah, just moment. Okay, so see here, this is your door and you're opening it from here, right? If you apply the force Fa, you apply less force compared to Fb. So what do we call this point? This point is called the pivot, the turning point, or you call it the fulcrum. Okay, keep that in mind, yeah? So we have the term lever arm or moment arm. So this is like the arm, okay? So the distance from the lever arm and the force, so this is the force and this is the radius from the pivot or the distance from the pivot to the point where you apply the force, okay? So I want to calculate torque. Torque is equals to this distance, Ra, multiplied by the force applied here, Fa. So this is torque at A. How about at B? Torque at B will be Rb here multiplied by the force Fb. Okay, so this is the concept of torque.